There we are. Hello. Welcome, everybody. Hello, Kango Fango. Welcome. Hello, Mr. W. Welcome. There we are. That's being picked up. I thought that was muted. 1 second. There we go. That's better. Right. So, there's also someone else watching with an account or without an account. I don't know. But hello to you as well. How has everyone been so far? Not just for this stream thus far. I meant more a couple of days, sort of that range. Maybe it's already been answered in chat. So, hey everyone, hey, how are you all today? Not bad, but been a busy day. Yourself? I'm going to answer that question as if it were addressed to me, even though I know it wasn't. Well, I've been working on Ghostly Venture quite a bit, doing quite a bit of modeling work, coding, that sort of thing. Also, I was out in it's a big kind of section, it's kind of woodland-esque. It's more of a park. Well, it's kind of partially like a park, but a lot of it is also woodland. In this town, just surrounded by houses. And it was very nice. It was quite a warm day, sunny. It was very nice. Plus, it's also quite hilly, so that's also good. Alright, yeah, I've been alright, thanks. Anything in particular? Work-wise? Yes, if you don't mind, of course. Meh. Had a piece of homework to give in, but it was mostly, not modestly. Mostly, 1 second, let me just change that. It's a bit dark. But it was mostly revision and just things kept coming up. Oh, I see. Trace, this park forest, was it in Ghostly Venture or IRL? No, it was in real life. I said it was a sunny day. The sun does not shine in Ghostly Venture because it is night continuously. The skybox does not change. So, yeah, how it could not have been in Ghostly Venture. Unless I did something which I haven't told you yet, which I have done stuff like that, but nothing to do with this. Oh, of course, no sun, of course. Okay. So, I know you can't see it yet. Don't worry, I know. I just want to switch to the correct scene in the background. Right. There we are. So, I've done some stuff, and there is... Hold on, I need to fix the error first. I need to... 1 second. This is line 18. Why line 18? Huh. Not sure why that is. Does not contain a definition for position. Oh, right, of course. Needs to be transform. There we go. Quick little error I fixed. I know you can't see it yet. That's on purpose. There we go. So, I know. Don't know either. Wait, what? What do you mean? Oh, of course. XD. I'm not sure what you mean. Right, so, a thing I've done... let's see, I'll need to find... Oh, it's back there. Good. I've done a little bit more work on the ceilings in the corridors. Of course. That is what you said about the error. Oh, that. Yeah. Sorry. Right, so if we go into here, you can see, well, for one thing, there are a lot more corridors generating because I've added the ceiling to both the north-south and the east-west corridors, as well as all of the T intersections. One thing I've done is I tweaked the bricks a bit, so they are now no longer sticking out as much, like they're not as beveled as before. And the same thing on the ceiling. And I also changed up the keystone row to be just normal bricks. I started working on texturing up there as well. That's not finished, so you can see there's a bit of texturing there. No normal maps yet, but yes, I think it looks quite good. It is mirrored, so the left side and the right side are the same, and you can kind of see that by that little seam in the middle there. But that will be fixed, and then you won't really notice it. And this way, it's just much easier to do it this way. Here we go. This is the other thing that I did in the ceilings, is I implemented a T section, which we're in at the moment. You can see the corridor comes from back there, goes that way, and it goes that way. And this bit is where the ceiling merges. You can see the arches as they come in, and then there is a 90-degree turn where the arch comes up to the ceiling. And hold on, are those two faces? Yes, they are. I will need to change that. Anyway, yes, comes in. This one doesn't have a material yet, so which is why it has a different color than the other one. But yeah, that's stuff I've been doing. I think it looks quite good. Obviously still needs work to do, but I think it looks quite good. So it still doesn't have a collider, so you can still just jump right through it. But if we walk through here, you can much more closely imagine it, like it will be when it's finished, like walking into here and then looking in there. This will of course have a roof. Yes, the 90-degree turns don't have ceilings yet. Then you walk along here, look down that way, you can see another corridor going that way, and this is, I believe, the same one we were looking at before. No, it's a little bit of a different one, I think. Yes, these ones are just going parallel to each other. This one merges in here, and it goes off this way, going down here. You can see how easy it will be to get lost in these corridors, right? And yes, then they both end here. Yes, so that is one thing I've done. Let me just quickly change that little face issue I noticed. So, where is it? This one. Edit mode. Where was it? Let me make this a bit smaller. Hello back. Hello, no, sorry, that's the wrong sentence. Not hello back, there's something supposed to go in between that. No, it's, what was it? Hello, I am back? That sounds okay. That sounds like it was probably the right sentence. So, right, what happened was, while resizing Blender, the computer froze. After a little while, came back, Blender had crashed, Unity had crashed. I decided to restart. That took a long time. Then after it had finished restarting, I opened up, well, actually no, I tried opening up Unity before, but it took ages rebuilding the project. And then I tried restarting, then when I came back, and then, well, I typed in the chat, I rebuilt the project again. Now Unity's open. I've opened up Blender, resized it. So we should be good to go. Should be good to go. So I don't know if I should read the entirety of chat, because there's been stuff typed there. Should I? Should I read the chat? All the stuff that's been typed since... I'll leave it up to you. Should I? Should I read chat? Chat, tell me, should I read you? For what happened before? Do it. No, don't. Do it, please. Okay, well, one of you said please, so I'm going to do that. It'll be gone forever if you don't. Forever! Everything is going to be gone forever anyways, at some point. So, anyway. Sure. I'll try to make it a bit quicker if I can. So where were we? What you said about the error? Ceilings! Oh, looks so great! Yes, looks very good. Beautiful work. Very lost very quickly. Lovely. Roman tile set dot blend. Not a link. Froze. Yep. Yeah, it's kind of buffering for me. Oh, works now. Not anymore. That's weird. Try stopping and restarting. Just try stopping and starting the stream again, maybe. Restart it. Alright, ing. Oh, for pity's sake. Or piety's sake. Sakes, rather. Should be back relatively soon. Yeah, right. There's a link to this Twitch status, which is... It wasn't Twitch's fault this time. Alright, Paradise. Let's hope it works. No, it's on my end. Alright. I can hear owls. Yay! Are they in pain? Owl. Oh, I hope not. Likewise. Hold on. Tight. Unity's opening back up. It's taking a while to initialize the database. It did. Oh, I see. Alright, yeah, I've posted a picture on Discord as well of the little loading bar. It's in that channel. Actually, that's a good point. 1 second. I should probably let them know that I'm live again. So, 1 second. I know it's a long second. Don't mind it. Okay, so... Oh, I see. Alright, let's hope for the best. Looks like it's rebuilding the project. This could take a while. So, anybody learn anything interesting today? Oh, I have! I've learned this. Yes, try nice? Hands, microphone. That. I've learned that. Uh-oh. Yes? I was typing, yeah. I've learned that when steel coils are manufactured, they use hydraulic presses, but when the steel gets compressed enough, the press is too weak to compress it even more. So they put steel bars between the glowing red-hot coil and the press plate to force the pressure on that part only, focus the pressure on that part only. Then they rotate the bar and press again. Yeah, so they have a thing, they press it down, but then they put a bar across, press on that, so then it only presses this little bit down. And they rotate the bar a bit, press down again, rotate it again, press and press and press, so that they can focus all the pressure on little parts of the surface incrementally, so that, well, they can compress it further than the press would otherwise allow. Actually, yes, yes? Okay, this is a bit strange. Yes, very nice indeed. I think I really should restart my computer before continuing. Yes, also I'll turn this light off, just in case. To the message above, very nice indeed, look at that, yes. I'll be another few minutes. Minutes, sure. Alright, it's probably for the best. See you soon. Why is it always the game dev streams that seem to have the most problems? Well, previously, when it was Twitch having issues, I think it was just either random chance, or maybe the Twitch servers were overloaded on Fridays more because on Friday more people stream, and that's why Twitch was having more issues. That could also be the case. But in this case it wasn't. It was just a crash on my end. Oh, I should have saved before and auto-saved. No, it's a joke, don't worry. Nothing's lost that I'm aware of. Where was I? At least you'll be able to keep us posted while you're restarting, Shredders. Yes, because I know your addresses. Haha. Maybe Twitch gets confused if you don't set a category for the stream. No, because you can't set a custom one. You have to pick one that is recommended by them. So I can't put in Ghostly Venture or game development because it won't let me. Maybe, but that shouldn't mean he has to restart his computer. True. Mr. W, it was Twitch's fault in previous streams, and now it seems that Blender didn't like me, should be me, resizing it in texture paint mode. I accidentally wrote B. Yeah, you're right, my answer wasn't really meant seriously. Jokes aside though, I don't know. That is really bizarre, Shadows. Maybe Blender has stage fright? Blender, this is your stage call. Oh, for God's sake. Ahem. Get the peep. Peep? No, oh, right, sensor. Beep, yes. It's little stars. Out here, mate. Who was in there? Don't scare him. Imagine that in a stage. Imagine that in a stage. Someone doesn't come out, and one of the people on the stage yells at them, completely breaking character. Yeah. A good actor would incorporate that into the story. Improvise, as they say. Yeah, but a funny actor, one who has just given up and does not care anymore, gruntled, disheveled, not very well off. It is progressing, sorry. Alright, to both. Almost back in. This was while it was still restarting. Good. For example, if the actor that's supposed to come onto the stage is William Treftis, but is extremely nervous, stays in the wings, the character that's currently on stage grabs the telephone and says, "William Treftis, wake up and come here." He could then hang up and improvise, saying the following: "Oh, William Treftis is just the ice cream man yesterday. Yesterday he said he wanted to come by, but it seems that he has dozed off." Yeah. Back in. Yay. Now I've got to wait for it to set itself up, which also happened. Good. Also, wouldn't it be fun to do an entirely improvised 10-minute monologue stage performance where the only thing you've got is an armchair and an old wooden coffee table and a black rotary dial telephone? Well, if you're doing a lot of exposition, that is kind of like what GMing a game is. Or really, yeah, well, GMing a game. If you're setting up scenes and you're talking as NPCs and that whole thing, then you can easily get a 10-minute long improvised monologue in there. And if you're doing it well, then it won't annoy your players, but rather they will be interested to hear what you have to say. If you're not doing it correctly, then they're just gonna be a bit bored while you're just expositing. Anyway, starting Unity, indeed. Yay, Z's. Yay, Z's. Also, the dot after telephone is supposed to be a question mark. Yes, it would be fun, I think. Looks like it's rebuilding the project again. Oh, should not be long, hopefully. Importing. Alright, it's open. Now I'll resize Blender before starting stream again. I did do that. It jumped. Great, let's hope it works. Okay. Yako. Okay. Yako. Okay. Yiko. Here we go, in yellow. Hello back, XD. Hello, almost an hour, but... hello again? Yes. Welcome back? Yep. I be back. Good. You can run and you can hide, but my nav system will hopefully find you. Yes, that is the system. That is the name of the stream. You can run and you can hide, but my nav system will hopefully find you. If you're a stereotypical pirate, sure. Shadows, I see. Hopefully nothing is damaged. I don't think so. No, don't. Shadows, do it. Please. It'll be gone forever if you don't. Forever. There's not really any point, I'd argue. Yes, but if he enjoys it, then I will say it. Curse you and your willy manners, Kango. Wily manners. True, but everyone sees the presses. True, but everyone sees the presses. It'll get cut off if you don't. Oh, for Titan's sake. Yes, because the Titans aren't technically... Well, they are kind of gods. They are gods, but they're not the Olympians. They're above the Olympians. The Titans... The Olympians came from the Titans. It's an interesting thing. Actually, that dates back even to pre-Hellenistic time periods. It dates back pre-Bronze Age. For example, I think Aphrodite has her heritage in... Stone Age people's religions, and it's very, very interesting. If you get a chance to look into ancient religions and their origins, I would strongly suggest that you do if you find that sort of stuff at all interesting. Or even just if you find anthropology interesting. XD Sharadise was like, hey. I said, not uh-oh. Yes. He knows my address. Eek. Sakes, not sake, but yep. Okay. You see, nice. Now that that's done, the stream is basically over. Just doing shoutouts now, and then I mentioned that the stream will be archived, and that'll be it. So, Kangafango, he does lovely stuff on... Actually, wait a minute. Oh. What's that? Oh wait, we've still got an hour. Right. Yeah, don't worry, I'll make something. Yeah. That was a funny joke, right? Yeah. Yes, I was joking. Of course, I was only joking. You didn't think I was serious? No. Of course, I wasn't. No, no, it was a joke. I got you though. I got you. Yeah. Anyway, we've got an hour left. Good. So, right. No, please. Who was that? Who was what? Who do you mean? Was there somebody that walked past in the background? Ha. Who do you mean? I don't know what you mean. Right, so I think we should start again. Unity's open. This is the thing that I wanted to show you, but we'll get to it in a bit. For now, let's look at this. So this is what I wanted to do. There was a face here. This one. Actually, no, there are two there. Actually, no. Are there? Where is this bit? Is it? No, it's not this one. There's a double face here. Up there, this is the bit. You can see up here, these two faces are on the mirrored side, because the right side of this model is mirrored, the left side is not. So this is twice, this is on the left side and the right side, and then that gets mirrored onto the left side, so it's Z-fighting. So if I delete these faces, then it should be fixed. There. Done. That is why I wanted to open Blender and to do that specific thing, not anything else, just that thing. And you can see how much of a snowball effect that has had. So let's overwrite this. Let me make sure it's selected objects only, export. There we go, save that, quit Blender. I'll never use it again, and so forth. Let's just see if this has been fixed now in-game or... there we go. Just quickly go into the corridor, have a look at one of the T intersections. Oh, in a forest. I still love how these trees look. I'm so happy with them. They don't have a texture yet, but that will come. That will come. Now, where is the entrance to the maze? Where is it? Actually, is there an... Oh, there is a spikes biome. Not biome. I keep calling them biomes. They're actually just terrain tiles. Over here. Because a biome is an ecosystem. Well, actually, it is a... Well, yeah, it is more of a collection of ecosystems, I think. So if I climb one of these... Let's see, can I see the maze entrance from here? I think... no, I'm not sure. Might be behind some of these hills. I'll reload. Get one that's a bit closer. Oh, well, this, I guess, is technically a bit closer. It's literally right where I spawn. Clip that. That is hilarious. Oh, I want to get one where it's a bit closer. Restarts, spawns inside the thing. That's funny. That is funny. Right. And of course that doesn't work. Oh, yes, of course. Wait, did it? Ah, you can see the key is teleporting in and out. Because the key, I'm teleporting, but the key does not. So that is why that disappeared. Right, so let's see. Yes, that's better. Now we don't get that strange, bright face in there. Now it's much better. Right, so yes, corridors. I've done work on them. You can see, still needs a lot of work to do. But it is getting there. It is getting there. Nice little forest up there. Anyway, Oh, alright, Sharedice. XD, Sharedice. Love them. Just slap the rock texture on the trees as a placeholder. No. This is not Scaro in its first appearance. Ha 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 ha, Sharedice. XD, XD, XD. On it now. Clip it, Kango. Yeah, he's on it now. Also, I've heard. Right, so the other thing I've been working on is this. This is my node-based AI navigation test thing. So this is meant... So, okay. Not Caro. No, Scaro. I said Scaro. There's the clip. Thank you very much. Something went wrong. We couldn't find that clip, it says. It says something went wrong. We couldn't find that clip. Ooh, the ghosts are spooky already. Sharedice, what is Scaro? Scaro? Oh, I thought you knew Doctor Who. My mistake. Scaro, the home planet of the Daleks. If you remember the first episode in which they appeared, first ever season, like episode 2 or 3 or something like that, they came to this planet with petrified trees. They were petrified by radiation, so they were literally turned to rock. Like a forest of rock trees. That's why. Still can't find the clip for me. Maybe I need to reload the page. That's okay. As long as the clip actually... we can make it afterwards if it didn't work. Right, so, yeah. And that's where they find the Daleks, because there was a huge war there with lots of radiation and things which has petrified most of the planet. If I remember correctly. It's been a long time since I've seen that episode. But yeah, so... since you said slap a rock texture on the trees, I thought there was an opportunity for a reference there, but apparently it was not received well. So... Are you sure? Yeah, I'm sure. Works for me. Sharedice, yeah, I do know a bit of it, but don't remember all the names and such. Come on, Scaro, that's said so many times. Scaro, the planet that of the Daleks. Anyway, sorry for not getting. Alright, sorry for not getting it, Sharedice. It's okay, don't worry. It's fine. Right, so there is an AI navigation system built into Unity. It is it's called the Nav Mesh system. So Nav is short for navigation, which you use. The way you use that is if you've got a scene, you can bake a mesh on top of that where all the walkable areas are, and then if you put an agent in there, which is a term used to describe a thing that moves around on the in a navigation system, and it will pathfind the shortest path to its destination along the generated navigation mesh on the floor, which is invisible to the player, of course. So, the issue with that is that since it has to be... Okay, so the word baked means it has to be pre-made. It's not runtime. So if you've got runtime and if you've got baked, this also applies to lighting and other things, textures as well. If something's baked, it means it's made ahead of time, so it's pre-made when the game runs and then just accesses that. It doesn't do it on the fly, so to say. The issue with that is I'm generating my terrain randomly, along with the mazes, so I can't really use that. There are ways I could get around it. For example, if I had the entire floor of the maze one plane, and I only put the walls on that don't have a floor, then I could mark the walls as being obstructions, which then it would dynamically cut holes out of the nav mesh where the walls are, and that would work. That would work. I could do it that way, but I think that in future I do want to work more with verticality as well with the mazes, which that would not support. There is an add-on, I believe, which it is free. There is a free add-on, I believe, which allows you to dynamically generate nav meshes at runtime, which I could use that, but I've not used the net code. That's for an older version of Unity. There might be issues with that. I'm not really that well versed on how exactly Unity's how the API for Unity's Nav Mesh system works. So I'm not going to use that unless this doesn't work. If this doesn't work, then I may use that. So what I'm doing now, what I've started doing, is implementing my own navigation-based system. I want to do this using nodes. It's going to be kind of similar to A-star pathfinding system, if you know what that is. If you don't, then that's fine, doesn't matter. So you can see the green dots you can see them like this a bit better. You can see the green dots here on the red surface. Those are navigation nodes. And in this example, the ball, so over here, the ball is the agent, that's the thing that actually moves, and the cube over here is its target, its destination. So the way I want this to work is that the cube, the sphere the sphere, first thing, the sphere needs to check, okay, can I see my target? If yes, then it just moves towards the target. If no, if there's something in the way, if it's obstructed, then it says, okay, I need to find my closest node, which in this case would be probably this one. And then it's going to tell that node to find a path. This node is going to look, okay, which nodes can I see? And then it will tell each of those nodes. So for example, it will tell this one, and that one, and that one, and that one, and down here. If this is enclosed, we'll tell those nodes, okay, find a path. And these are the nodes that have been visited so far, which is only me. Actually, no, the node will look, okay, can I see the target? No, then look for another node that I can see. Then that node will check, oh, can I see the target? Yes, if yes, then it will take that path of nodes, which is firstly the target, then this node, and then that node, that list of nodes, that path, and will report that back to the agent, which will then move to each node along the path. If this node cannot see the target over here, if it can't see the target, then it will go through all of the nodes that it can see. We'll tell them, okay, we're looking for a path. This is our agent, this is our target, and this is the path we have so far, which is that, so node number 1, node 2, node 3 so far. And then this one, let's say there's just a corner here, just sort of like this. So this node can actually see this node, but this node cannot see the target. So then it will go to this node, and will say, this node will say, okay, can I see the destination? Can I see the target? And say, yes, I can. So it sees that, and says, okay, I can see it. So now, this is my path. This is the path that I've inherited, so to say, from the previous nodes in the path, which is from the agent to this node, and then to this node. It will take this path. Again, it will report it back to the agent, and this agent will look at the list and say, okay, the first item in the list is this node, then it will move to this node. Then, if it's close enough to this node, it will increase the index, so it will go to the next node in the list, go over to this node, then we'll go to the next node, then as soon as it gets around this imaginary corner, it will go, oh, I can see the player, I can see the target, the destination. And then it will forget the rest of its path, because it doesn't need it anymore, it has the player. And then, or the target, and then it will go towards the target. If the target has moved in that time, the way I want this is that when it reaches the final point in the destination, the final point in the list, the path, then depending on how I want the AI to work, either it just stays there. If it has just completely lost the player now, it doesn't know where the player is, the player has escaped, or the target has escaped, it's just going to stay there, just going to wait there. That's one option. Another option is that it knows where the player is again, it looks for the player. So then this node is the closest the one it's at, and then this node will do the same thing again. It will go to all the nodes around it, see does any of those see the player, and then on and on and on, and so forth. So that is the basic system behind, or the basic idea behind how I want the system to work. There are some issues with this. The main issue is that it is not very performance efficient, seeing as, also by the way, one more thing is that each node will only tell nodes that to look for a path that have not been activated yet. So for example, this node here sees that node up here. Actually, no, let's do it the other way around. This node here sees this node. So it will tell this node to look for a path. Then this node doesn't see the player or the target, so it will contact all of the nodes it can see and tell them to look for the player. Now this node has to already see the node that it came from. But this node will not be triggered again because it has already tried to look for the player and it has not succeeded. Otherwise we'll just get into an infinite loop where this node will contact that one and that one will contact this one and this one will contact that one and so forth. And that's an important bit. The thing why it's a bit inefficient is that it will check this way. It's basically growing out the network of searching until it finds the thing, which means that it is checking nodes that are getting further and further away from the player. If I wanted to do this more efficiently, I could make it so that it looks at all of the nodes it has, all of the nodes available, that by all of the nodes that are connecting to a node that has already been checked, it finds the one that is closest to the player or the target, and it checks if that one can see it. So that way it kind of hugs the walls that are the closest to the player, which will prevent it from looking at nodes that are leading away from the destination. But so that would drastically improve performance of it, but that is really only an issue if it has to run like every frame, if it has to dynamically every frame do it. But if it's a thing where it only really happens maybe once a second or so, then you will not notice it. That will not impact the performance. Well, technically it does, because every calculation impacts the performance, but it won't do it in a noticeable way. It's just so minute. Yeah. Thing number 2 is that this system will only allow one agent to find a path at a time. So if I have an agent here, and I have another agent here, then if this agent wants to find a path to the player, it will say this node is the, actually, well, let's move it here. It will say this node is the closest. So this one will then see all of these nodes over here, and we'll check those. But then if this one tries to find a path as well, it will see this node, and then we'll see this node and try to check this one as well, but this one's already been checked, so it wouldn't be able to check this one, which means that they can't do it simultaneously. So I have to put in a barrier, a boolean, so that if there is an agent already trying to find a path, the other agent just can't get through. It will try again and again and again and again. Probably every frame it'll try, can I do it now? Can I do it now? Can I do it now? Until the agent that's currently looking for a path either finds the path or it times out, which I'm thinking like maybe a second should be plenty of time. Well, we could make it like 5 seconds just to be sure. And then it will change the boolean over, and then the first agent that gets in again will then be able to basically get their turn to find a path along the system. Which again, if there were a lot of agents moving around this system at once, dynamically trying to find updating their path constantly, then this would be very inefficient and it could cause quite a few issues with the navigation. But since this is only basically going to be used so that if a ghost sees you in the corridor, you run away, that the ghost can still chase you for a little while around corners as well, so that it doesn't just stop as soon as you turn a corner, but that it can actually follow you and turn the corner, at least for a while. I'll probably have some timer where if it hasn't seen you for like 10 seconds, then it has lost you and will stop. Something like that. So that is the plan. I'll read chat. Oh, actually, 1 second. So we're not getting it, chat eyes, that's okay. Kango says, oh, I see. Intriguing. Will ghosts be able to float up and down through the levels? Well, that is an interesting question. Because another interesting question is, how will the ghosts handle the exits/entrances? Will entities, will agents be able to exit the maze, follow the player to the exit of the maze? So through the exit, is that a thing? Is that going to be a thing? Or if something is chasing you outside, you run into the maze, will that thing chase you into the maze? The easy answer would be no, it doesn't. I could try to do it so that if the player enters the maze, then if something is chasing the player, it then gets updated so it no longer looks for the player themselves, but rather looks for the entrance or exit that the player used. It will get there, get teleported up. As soon as it gets teleported, it then updates back to looking for the player. That is a way I could implement it, but that would add another layer of complexity to it, which I just can't tell if I would want to have that at this point. When I've got the basic navigation system in, then that is something I can look at. So, yes. And yeah, that same thing goes for floating up and down levels as well. Although technically, if the levels actually connect, like if the nodes actually connect if they actually go down the stairs, then because this node sees that node and that one sees that one, this navigation system should work in 3D as well. It doesn't have to be on a 2D plane, so moving down would work, and those nodes above each other wouldn't be able to see each other because of the floors in the way, so it wouldn't try to pathfind that way. So actually making them follow the player to different levels, if I want to implement different levels, that is, then that shouldn't really be an issue. The system should be able to support that. So, okay. If you can answer. I have, I think. Oh, they're green. Yes, they are. It's a bit difficult to see, I know. If I zoom in a bit, then you can see it more clearly. There you go. Thought they were cyan at first. Shanace, what's the sight range on the nodes? That is basically, it is going to be, it's okay, that is something which I may implement. It depends on what I use them for. If I use them inside the mazes, then should really be okay. There shouldn't really be that big of an issue because there was in place. If I use them up above on the ground level, basically on the actual terrain, then a node could potentially see hundreds of other nodes, and then all of those nodes would have to be checked through and triggered to see if they see the player. If I implement a range that nodes can see other nodes, then that means that only those nodes will get triggered per interval, which is something that I will probably do when I've got the basic system working. Or radius. Also, A-star pathfinding. I've heard of it, but I don't really know anything more. Yeah, well, it's basically similar to my node system, only it uses distances as well. So it keeps track of distance to the player, and it keeps track of distance walked, and then I think it averages those together, or it adds those together, and then it keeps track of all of the different tiles that are adjacent to tiles that have already been explored. And then the one with the lowest value, so the one that is closest to the player, both in actual distance and in distance walked to get to that place, is going to be the one that it explores next. So that if there's an open field, and there's the player here, and there's the target here, there's the agent there, it will go towards the ones that are closest first, so it will only pathfind towards the player. If there's a wall in the way, we'll go there, look for the close one, we'll look up there, then look down there, look up there until it finds the edge, and then it'll go straight to the player. Which is a clever way of doing it, because it is quite performance effective. Or efficient, I guess. But that is I think that is too much for what I need. I think what I have planned should suffice for what I need it for. Maybe I just don't remember it. Actually, Unity have done in the past, years ago, they've done live training, so live streams, training. And the series of those, it might have been something else. Okay, I think they did some on A-Star Pathfinding, but Sebastian League on YouTube has a series dedicated to A-Star Pathfinding, I believe. Not completely sure. If you're interested in that, have a look at that, if that is indeed what I remember it to be. Alright, Shadows. Also, if your maze will feature doors, how will that affect the pathfinding? Not at all, since they'd be ghosts? No, it will. Because these ghosts can't really... Okay, I could make it so that they can go through doors, but I don't want them to... I don't want you to walk up to a door, and the ghost just comes out of the door and snatches you. That's not snatches you, but snatches your memory shard, which is... I just don't want that. That's unfair and it's not fun. So doors will be able to block line of sight, which means they will be able to block the pathfinding as well, because the pathfinding from node to node will use line of sight. It'll hack the walls, or... No, it won't. My system won't. Oh, they'll follow you around corners? Well, that's just perfect. Well, that's the idea. XDD. Hello, hello, V'ger. Hey. So, baboozle the player? Of course, always. Not sure what that was exactly referring to. V'ger, it's Paradise. It's a given that it's going to happen. Well, perhaps. Yeah, so just thinking about it now, I think it would be good if the things would chase you through the entrance-exit, because say something chasing you, and you run into the maze, would the chaser just freeze in place where the entrance is, and you'd be trapped in the maze? No, if it's something that's chasing you around there, then it will probably go back to roaming mode, where it will just walk around aimlessly, basically, freeing up that spot. Yes. Also, in some cases, it could be realistic that something doesn't chase you into the maze because it knows what lurks in the maze, and so it doesn't want to chase you in there. Like, for example, if you're being hunted down by a wolf, just as an example, I know wolves don't really go for humans unless they're really in dire situation, but say a wolf is chasing you, you run into a cave. The wolf smells that it's a bear cave, then the wolf will probably not chase you into the cave. It'll probably wait around nearby to see if you get chased out by a bear. XD, haha. Ooh, lovely green dots, thanks. I know it was an hour of technical difficulties, but the wait was worth it. Really enjoying this. Sebastian League, Do you mean Sebastian Leg? Yeah, isn't that Sebastian League? Isn't that pronounced League or Leg? Sebastian Leg. I've heard it pronounced Sebastian League before. Might not be sure. That might be wrong, sorry. I think that's him, yeah. Wolves and bears, always great examples. Sure. Right. Okay, so... What have I got so far? Actually, can I select these? Yeah, it works good. Need to open up the scripts. Where is it? Where are ya? Okay, let me zoom in a bit. So, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There we go. This is, I think, the size I was using. Thanks for reading chat. Sure, no problem. Right, so this is what I've got so far about the Nav Agent, the navigation agent. This is the thing that'll move around. So far, I've just got it so that if you press return on the keyboard, that it then looks for a path. So it gets a list of all nodes, and then it finds the closest node to where you are, which is where the pathfinding is supposed to start from. And then it sets that node's nav agent and nav target. Nav agent is this. Target is what I've set in this script in the inspector. And then it will trigger find path. Getting path false is just put in here so we can repeat it. This will not stay here. Anyway, so now if I go to the nav node, which you see find path function here, which is being triggered by this. So if you've got starting node.find path, which will go to the starting node, which is the closest node to the agent's nav node script. And you can see it's got a finish here, not a finish, function here called finish path. Yes, it's got variables. So this is what will contain the nav agent, the target, which are set by the nav agent itself, like I showed you before. It's got a list of nodes, which is the path that has been taken to get to this point. So you've gone through all of these nodes to get up here. Then all of each node basically inherits a path, and it adds itself to the top. And then when it tells all of the nodes it can see to look for a path, it will give them a copy of this path, because this path that keeps growing will be the path that the agent receives to follow from node to node to get to the target. Because the first path that finds the target will likely be, well, it should be the shortest path. Right, so each node keeps track of the path that it has had to have that was taken to get to it. Right. Visible nodes, this list is a list that will contain all of the nodes that this node can see. So like you said, it goes to this node, looks for all the nodes it can see, and then it'll tell all of them to look for a path to the target. This list will contain those. In this function, so when find path actually gets called, when we're actually looking for a path, it will add itself to the top of the list of nodes it has taken to get to this place. So it will add itself to this list. Then it will get all of the nodes. And then this is where... Okay, this is where I got to. So before... Actually, no, I can put that in the other thing as well. Else. 1 second. That's not right. It shouldn't be Nav Agent. It should be Nav Target. Right, so if there are no colliders between them, then it should do this. Actually, no. Then it should do... If there are colliders between them, then it should do this. Right. Sorry. Yeah, so before it looks for any nodes around itself and tries to find more of a path towards the target, it needs to look and see if it can itself see the target. Because if it can see the target, that means we've already found a path. We don't need to look further for a path. So this is what this does. It is going to cast a line, so from target to destination, a ray basically, a line between the 2 points. So between this node's position and the target's position. This function returns true if there is a collider between them, because it looks for a collider between those 2 points. If it finds a collider, it means something's blocking line of sight. We go into else, and that's where we do all the pathfinding stuff, all the code. If there is no collider between those 2 points, then it just needs to take its path, the path it currently has, give it to the agent which will then basically just cancel the navigation, the pathfinding, because the agent then knows where to go. Right, so thanks for the upsize. Though a question, was it on dark mode before? Yes, it was. I've turned it up to light mode because we had a few really sunny days, really bright days, and I was working on it on those, so I've turned it to light mode. I think it was a bit better readable. Was it? Oh. Well. Perhaps. If you prefer, actually, it might be a bit more easily readable if I change the color scheme. Is that better? Actually, no, that's not better because it doesn't have the same. It doesn't have the same highlighting. No, that was the dark theme. 1 second, I want to try a light theme. This one might be a bit better, a bit more easily readable. So it was like this before. If I change it to this, is that okay for you? Can you read it better like this? But still, thanks. Finish path. Where? In Finland, of course. Find path. Hi, hello, Chris. Welcome. You joined me after technical issue. Well, you joined us after technical issues and lots of explanations. Basically, lots of exposition / monologue that was improvised. So there you go. Hey. Heyo. This one's good. Thank you. Alright, Paradise. Thanks. Well, sure. Right. So, if it sees the player, or the target, I keep saying player, but it is not specifically the thing. I thought finish path was a function. No, it's find path. If I said finish path, then that was incorrect. It's supposed to be find path. So let's see what to do here. If it can see the player, then it needs to update the agent's path. No, not getting path. Where is it? Path nodes. Sorry. Let's just rename this to path. That's easier. Now we go over to here. If we can see the player, the target, then we need to do Nav Agent dot path is equal to path. So this first path is the path variable of the Nav Agent. The second path is our path variable. So we're overwriting the Nav Agent's path variable with our path variable. And now we need to do something to just stop to reset all of the nodes, basically, to reset all of them. Because we've now got a path. All of the nodes that have previously already been set need to be reset, basically, which reminds me I need to have a public bool, what to call it? Activated, maybe? No. Well, searched. Let's call it searched. Searched node. This is false by default, which is good. I do need to set it to true here, so we add it to the list, and we do searched node is equal to true. This is just so that it basically doesn't get into an infinite loop. So when I put the navigation code in here, it will go through all of the nav nodes it can see, and it will check whether a specific nav node, the searched node variable, if it's false, so if this has not tried to find a path yet, then it will tell it to find a path. If it is true, it will ignore it, so we don't get infinite loops. Public bool, active nodes. Nope. Alright. Alright, good. Right, so we set it to true. Now to reset it. The easiest way of doing this is probably for the node that finds the player, or the target, to just loop through every single node in the scene and reset them all. So we need a for loop for that. Well, actually, we need a list for that first. So actually, because we need it in both cases, I'm going to move this out of there as well, because we need all nodes either case. So in this case, if we do find the player, we need to have access to all nodes to reset them. If we have not found the player, we need access to all nodes to see which nodes we can see and then tell them to look for the player. By the way, if I say player and target, I use them interchangeably. It's just because I'm picturing the player, but actually no, it's the target anyway. So if we see the player, we need a for loop. So for int I is equal to 0, if I is less than all nodes dot length, then I plus plus, and then with everything we put in here is supposed to be done per node. So go to, actually, yeah, that should work. So go to all nodes, index of I, so the one we're currently at, and we need to reset it. So we need to do dot searched node is equal to false, then all nodes I dot nav agent is equal to null, all nodes, actually, tell you what, I'll just copy, no, not all of that, I'll copy this just because it's easier if I need this to paste it, and then do nav target is equal to null. Null just means no value. Null, well, null is actually just another word for 0. So null in German, null means, null in German literally means 0. In terms of C#, most other coding languages as well, null refers to no value. So there's a difference between setting a variable to 0 or setting it to no value. Imagine if you've got a box, like it's an integer, you've got a box which is the variable. If you look inside, you can see, oh, there's a 0 in there. It's containing something, it's containing the number 0. If you set it to null, you just basically take everything out of the box, it's empty, there's nothing in it. So there's a difference between the two. So we're setting nav target to null. Okay, we need to reset the path, which is then going to be all nodes I dot path dot clear. Clear is a function of the list method, of the list variable. So you can see we've got a list up here, and that, so variables of the type of list, which this is path, has a function called clear that will basically just reset the list. It's basically saying we turn the list into null. Visible nodes as well. So all nodes dot, actually no, I can just paste it, haha. Dot visible nodes dot clear. There we go. That should be good for resetting it. We also need to tell the nav agent that getting path, that we finished getting the path, so we need to set that to false. So nav agent dot getting path is equal to false. Okay, so that means this is no longer, let's just keep, well, okay, let's disable this for now, comment it out. So what to do next? So we initiate the pathfinding. Actually, before we initiate the pathfinding, we should make sure that we cannot see the player. So, okay, sure. Of course. Can you path? So all of this, we need to make sure, basically we need to do the same thing we did with a node, which is this here. So only initiate the pathfinding if we cannot already see the target. So line cast from transformer position to is it called nav target? Yes, a nav target or transform position. So if we, no, this is if there are no colliders. So actually, okay, if there are colliders in the way, do all of that. If there are, actually no, other ways more, it's clear. So let's do it like this. Oh, that's the wrong bracket. It needs to be this one. Right, so if there are no colliders between the agent and the player, then we see the player and we can commence the chase. If we do not see the player, then we need to commence the pathfinding. So if we do see the player, let's just move towards it, just so we can test it. So let's put in a new variable, which is going to be a Sure, let's make it a transform. Why not? Actually, no, let's make it a vector3. That's more versatile. So, public. Actually, no, it needs to be underneath the other one. No, let's make this one public as well. Public. Okay, so public vector3, and this is move dest. So this is the point we're currently moving towards. So in update, need to do vector3 dot move. Is it move towards? I think that is a function, right? Move towards a vector, a multiplied vector, I think. Let's just look at let's just look that up, just to be sure. Oh, it needs to compile. 1 second. Scripting reference. There we go. Vector3 to move towards. Yes. We go current target, distance to move per call. Right, so move towards is fine. Yes, exactly. So, actually, wait, was that? Right. No, I'll just look it up because I'm not, it was, let's see which way around did the variables go in. Current target, yes. So, current is transform.position, target is move dest, and the speed I'm just going to set 1 times time dot delta time, just so that it delta timing something times. Okay, so delta time is the time, the real world amount of time it has taken from the previous frame to this frame. If I multiply a value by that, then it means it is it's not supposed to. For the majority of things, it will no longer be frame rate dependent. If the frame rate changes between frames, then it can get messed up, which means that if you run multiple timers using time to delta time, then they will increase at slightly different rates, which can be annoying if you're trying to sync things up. But for things like this, for movement stuff, it's fine, it's fine. So, let's rechat. Alright, very interesting. I'd love to get a box with a 0 inside of it. Oh, now I know what to get you. Don't worry. 0, yeah. Shades, here's a question. Will the ghosts always move around, or will they only move when you see the player? I think that depends on the ghost. Some of them, yes, they will only move when they see the player. Others will wander around. Because with this system, I don't have to give the player as a destination. I can just give a random node as a destination, and then the agent will move to that node. When the agent is there at the node, then I can just set another random destination, and so they will wander through the network. And they won't need to find a new path every time. They can just find a new path when they're at their destination. Right. Never heard move towards before. Oh, so it does exist. Nice. Oh, right. Nice. Queepy. Queepy? No, you mean quippy. Quippy, that is what you're looking for. Quippy. Shall so a bit like Pac-Man? Well, no, because in Pac-Man, the ghosts have different AI. There's a ghost that basically just chases the player. There's a ghost that chases the player but then runs away. There's a ghost that tries to cut off the player. The ghosts in Pac-Man actually have quite a bit of AI behind them. They're not just moving around randomly. Right, so. Oh yeah, I remember now. Good. So, who is still awake? Important question. Who is still awake? Right, so, move towards, transform position, move desk. Okay, so it's moving towards it. Now we need to set it. So, if we can see the player, or the target, I'm just going to do move dest is equal to nav target. Nav, yeah? Which means that unless we get an error, which we did get, what is it? Line 28, connect implicit convergence. Oh, right. Yeah, of course, because nav target is a transform, not vector 3. Vector 3, so I need to get dot position, like that. That's all good. So if I press play, actually no, I need to assign a target, so let's assign this target. So so the ball should start moving towards the cube, which it doesn't do. Why doesn't it do that? Oh, right, of course it doesn't, because... Ah, right. Yeah, that's an issue. The cube has a collider, so when the line hits that collider... That's interesting. I'll need to debug that, so let's see. Actually, let's see what is our move dest. Yeah, the move dest doesn't get set. So, oh right, of course. No, I didn't press return. There we go. We've got the thing, which means that it, yeah. Might need to do a layer or something like that. Right, so it set the coordinates, but it's not moving. Why isn't it moving? I have to move towards position. Maybe this is too low. Maybe if I do 100. Oh, of course. I'm not setting the position. I'm getting the value, but I'm not setting the position. Of course, that's it. So, transform.position equals that. Now, let's see if it works. Ah, it is moving. You can see, very slowly. Let's just implement a speed variable. Why not? Oops. Oh, I accidentally closed the thing. Didn't mean to close it before. So, let's do public float. Sure, let's do walk speed. And then we need to times it by that. Also, another thing I've noticed is that by default, since we're always moving towards move dest, and move dest by default is equal to 0, 0, 0 because we haven't given it a value, we're moving towards the center of the world, which is not what we want. If we don't have any point to move towards, I want it to just stay where it is. So I need to set a move dest to the position of this object, which I can do just in start. So void start, and let's do move dest is equal to transform.position. And then let's set the speed to like 10. Right? So I'm going to press play, shouldn't be moving. If I press return, it should start moving. Let's actually maximize this. Maximize. There you go. So if I press return, I can't maximize it because I need to press return in the other menu, sorry. Right, so if I zoom in a bit, if that works, return, you can see it starts moving, and it should be constantly tracking. No, it's not, because it's, yeah, that's right. So you can see it's heading towards where the cube is. Thing is, it's also going to head up to it. Like if I move it up here, you can see that it now just starts floating. It should also be able to go through the floor. Oh, why doesn't it do that? Huh. Oh, right, because it can't, yeah, right. See, it can't go through the floor because it doesn't see the cube anymore. Move it up here, now it... Oh, why doesn't it work? Huh. It appears that it is colliding with something. It's interesting. Huh. Oh, I know why. Because we tried, of course. You see, we tried. So when I pressed return and the ground was between the two, it couldn't see the player, so it went into this. So it's set getting path to true. And because we haven't finished the navigation code yet, it never set this to false. And you can see it only tries looking for the player if getting path is equal to false. So it didn't look for the path, so it didn't work, basically. Which means that... Nope, that should be fun. That should be fun. I'll deal with that later. So, raise his hand. I am awake. Okay, I'm still awake. Good. If that counts, I hope it counts. Do you think there's people that write their Unity 3D scripts on an actual typewriter, scan the sheet of paper, and then run it through a program that recognizes letters on an image and turns it into text, and then use that? I doubt it. But there are people who write out scripts like on a whiteboard, because there you can put drawings in as well and connect things a bit easier. There are people like that, yeah, and that is helpful, probably. Huh? Oh, of course. Ooh. Oh, that's weird. Does the floor have a collider? Yes, it does. It's stuck now. Oh, right. Alright. Yeah. Okay, so thing to fix number 1 is it can't count the target's collider as something hitting it. So we need to actually check whether we've hit something random or whether we've hit the target. So we need an out for that. So let's see. I think it uses raycast out. One second. Let me just make sure. So raycast hit. Sorry. Linecast. Huh. Doesn't look like it has. No, it has hit info. Strange. It lists up there but doesn't down there. Runs start end. True. If true is returned, info contain more information about the collider. Oh yeah, so it does work like that. Okay, so if I go here and go into raycast hit, new variable, raycast hit, and then I should be able to put this in here, comma out hit. Then I need to check, well, actually, there's from us to that, so it works. Actually, no. Wait. Okay, so if we don't hit anything there, then it's okay, go there. Or if... Wait, that's not right. Yeah, like that. No, I'll do it like this. Or if hit dot transform dot name. Actually, no, can I just compare the two? I should be able to. If hit transform is equal to nav target, which is a transform in itself, so I don't need to get the transform. So if we can, okay, so if we look at the target, there's nothing in the way. We can actually get to that point, then move towards it. Or if there is something between those two things, and so if there is something between those two things, but the transform of the object we hit is the thing we're looking for, then hold on. Then just do the same thing. Just go to it. But if the line to that object, to wherever we're going, has hit a collider, and it's not the same transform as what we're looking for, then we need to initiate the pathfinding, which means that unless I get an error. My cast hit transform cannot be assigned to its read-only is... Oh right, it needs to be equals equals, not equals. There we go, that should have worked. So now if I go to the target, and if I enable the collider again, then the ball should still be able to move to it. Yes, it does! Look at that. But now if I move this below the ground, yeah, it doesn't work anymore, because now it's no longer detecting the object, so it's not going into that. That's the whole thing where it got stuck before, but it's working. It's working, which means I need to actually implement this as well in the node. Actually, do I? If not between the two. So if we find no colliders between... Oh, that's wrong then. This code doesn't need to be in there, it needs to be down there. Right? Because this, if we do not find any colliders between where we are and the target, yeah, actually, no, wrong. This is already the code for it. Sorry, that's already good. I thought that was the navigation finding code, but that's not right. Here, we also need to check for if we are hitting the collider of the thing we're supposed to be looking for. So I'll just copy paste the variable name, out hit as well, paste that in there, and then out hit there. So if we don't hit anything, you know what, let's put this into a separate function, because otherwise we'd have duplicate code, which is never nice. So, well, it looks more impressive, like, oh, look at all these thousands of lines of code, even though most of it's just duplicated. Anyway, so void found target. Let's just put all of this code in there, and then let's just call that function from here. So found target, and let's fix the indentation. Right, so if we don't hit anything on our way to looking at the target, then we found it. Else if, and then we need to have another else there. So if we do hit something, but hit dot transform is equal to nav target dot transform, same thing as before, then we've also found our target. So that should work. So you see, otherwise we'd have to copy all this entire block text here and here. We'd have it duplicated, but this way it's just cleaner. It's much more easier to understand as well this way. So that works. Good. Good. So let's read it. All right, yeah, sure. Yay, it be working. More impressive. Yeah, of course it is. I mean, if you've got thousands of lines of code and you're like, for example, if you were streaming game development, but the people who are watching didn't know anything about game development, you've got the script where on the right it says line 2530 and you just scroll through and through. I don't know. You scroll through and so forth. Then it's just lines and lines and lines and lines and lines and lines. It's just a huge thing, but if you look at it, it's just half of it is just copied or basically copied, only with slight variations. Then yeah. But you're right. Yep, I've heard that thing is also true about really long lines of code. So if you've got a line of code that, like this one, there's a fairly long line. It's not that long, but there's a fairly long line of code. But if this one went on for much longer, like if I wrote an entire function, like for example, the thing public void get path, this entire function, I could get rid of the line breaks. I could write this all out in one line and it would still work. You'd have a lot of opening brackets, closing brackets, and that sort of thing. That can also look impressive. But I think that a longer script looks impressive than a wider script. But some people find that other thing impressive. Anyway. More impressive. But yeah, right. Yep, true. Haha. Yeah, true. Okay, so what to do? Right, so the node. If we can't see, I think vertically large scripts seem more impressive. Yeah, true. Right, so if we cannot see the player, if this node cannot see the player, then I need to have a look at what nodes I can see. Which means we need to loop through all of the nodes. We've already got an array containing all of the nodes, because here I'm making a new array, call it all nodes, setting it to the value of GameObject.find all objects of type nav mode. So the type that it speaks of here is a component. So it looks for all the objects in the scene with a component nav node that have the script nav node, puts them all in this array. So we've got all of the nav nodes, so we need to cycle through them. So for int I equals 0, I less than all nodes dot length, then I plus plus. So for each node, actually let's implement the range. Let's do it. Let's implement the range. That was a good suggestion, might as well implement it now. So let's put it in there. So public float let's call it let's call it site range. And let's default it to something like 20 meters. So first we need to check if the node we're currently looking at is within our range. So if or if vector 3, not vector 23, imagine a 23-dimensional vector. Interesting. If vector 3 dot distance, which is a function of vector 3, which compares to vectors output the distance. Effectively the distance between us, so transform.position, and all nodes, the current node dot transform dot position is less than sight range, which gets cut off on the right because of the large font. So if it is within range, then, and only then, do we check and see if we can actually see it. So if, and since the nodes do not have colliders, since the nodes don't have colliders, I don't need to check if we're hitting the node. We can just see if it reaches it. So let's rechat. Yeah, true. Nav node.cs. Yeah, exactly. Site radius. Oh, that. 5? Oh. Was about to say 10. Oh! Oh! 23 dimensions! Ah! They're all chasing me. The dimensions? XD. Haha. Good thought that. Scary, but very good. 11 out of 11. Would dimension again. Oh, by the way, so how are you all holding up in this? Kango Fango, Mr. W, V'ger, Chris, anybody else who's there, lurking, perhaps, Ghost Lady, how are you, if you're here? Are you here? Yes? No? No, I don't think she's here. Sweetar, if you're lurking, how are you? How are you all holding up? It's good to check in sometimes. Yeah, holding up good, thanks. Nice. Nice. Okay. So, that was in no way preparation for what is about to come. No, but seriously, it wasn't. Right, so now we just check the distance. So, if there are no colliders, so we invert the statement, so the check, so you're typing something large, Kango Fango, I can tell. Right, so putting an exclamation mark in front of a statement, like for example here, you've got exclamation mark physics.linecast, then it inverts the statement, so it basically means not. So, likewise, very much awake and watching wide-eyed. Haha, the preparation. Huh? Me? Yes, you. Okay. This time I wasn't. Oh. But good, because of time-related issues. Oh, we've gone past the time. We've gone past the time. We've gone past 10 o'clock. 8 to 9 to 10, yes. 2 hours gone. Over 2 hours gone. I'll just finish this bit. And then we can end. So, if we do not see it, so if not physics.linecast from transform.position to all nodes i.transform.position. So this means if we cannot see a line between where we are, where this node is, and the node that we're currently cycling through, so if we can see each other, if there's no collider between us, then it needs to tell that node to also look for the player. So then basically we need to do this. So we need to, what do we need to give it? So we need to give it the agent, the target, the path. So okay, the agent. So let's do all nodes i dot agent, nav agent is equal to nav agent. So we're setting the node that we're currently seeing, that we're cycling through, that node's nav agent variable we're setting to our own nav agent. So we're telling it, hey, this is the agent that wants to move. This is the thing you need to send the list, the path list back to when you found our destination. So actually, no, we need to check something else before that. So actually, yeah, the distance, sure. Before we do this, oops, Actually, no. Well, yeah, I guess before we do this. So if it's if the node is within range, we need to ask another thing, which is, has this node already been searched? So all nodes I, so the current one we're looping through, dot search node, and then invert that statement, which means, okay, is the node, so we're cycling through all of the nodes in the scene. Is the node I'm currently looking at, so the node I'm currently looking at, so the node of index I, is that within the range that I can see it? Yes? Okay. Is this node's searched node variable false, which is checked by the question mark. I could also do it like this, equals false. But by default, if you're checking for a bool, it always checks, is this true? So you can just invert that statement, so it checks, is this false? So just an exclamation mark up here. Anyway, which means, okay, it's within range, its searched node variable is false, so it has not been searched yet, which means this will prevent it going back and forth in an eternal loop. So it has not been searched yet. Then we check, okay, can we see this node? The physics part of this is probably taking the largest amount of processing power. So I'm putting this as the last step, so that if this fails or if this fails, it doesn't even get to this. So just a little performance thing. It is unnoticeable. This would not impact the performance that much at all. It's just a good habit to get into. So if it's within range, hasn't been searched, if there is no collider between us, then we want to tell that node that we're currently looking at to search for the player. So first things first, we tell it, okay, this is the nav agent, this is the object that wants to move, this is the object that you need to send the path list back to once the player has been found, if you find the player. If you don't find the player, you need to pass this on to the next nodes, so that if they find the player, they'll know who to send it back to. So that's done. What's next? Next, we need the target. Okay, so all nodes i.nav target is equal to nav target. Same thing as before, only instead now we're saying, okay, this is the thing you're looking for. If you find this thing, then you've succeeded. One more thing, which is the path. This is important because this path is the path that was necessary. Well, this is the path, a list of nodes that were taken to get to this node that we're currently at. And you can see up here, when we do find path, so when this node actually activates, it adds itself to the top of the list. So then if we write down there, if we give this list to the nodes that we see so that they can continue the path, then for them, when they get this node, when they get this path list, this node that we're currently at will already be in that list. And then they will add themselves to it. And so the list will grow and grow and grow until we found a node that can actually see the player, in which case it will take that path, bring it to the nav agent so that the nav agent can then follow those nodes, like I explained before. I realize that I'm repeating myself a bit. It's just because I do get that for people who aren't used to coding, this can be a bit daunting, a bit complicated, and I do want to try my best to make it as easy as possible for people to understand. So, all nodes i.path is equal to, now can I actually just set it? I should actually C# list.set. Do I have to set it, or can I just Okay, so I'm wondering if I can just set it with equals or if I need to call a function to set it. So, there's the wrong thing. This is what I need. Yes, I'm on the Microsoft website. C# is the documentation is of Microsoft because it is, after all, a thing. So anyway, right. So let's see. I've got. Where's the list of methods? This is what I want. So actually, it should be down. Is it down here somewhere? All right, it's here. So let's see. We've got add range. We could do add, but I don't think we need add. Add is if you want to add something, or if you want to set it. It would work, but I don't think we need it. Let's see. This is clear. This is the one I said before. When we cleared the list, removes all elements of a list. There we go. That's the one I was using. Copy 2 copies the entire list to a compatible one-dimensional array, starting at the beginning of the target array. Oh, that's actually quite interesting. So you can convert a list to an array. I believe you can also just cast it in Unity, so do as array, but I'm not completely sure. Find index, find last, index of, no, we don't need that. Insert, no. I mean, that would also work, but we don't need it. I think we can just set it like that, just with an equals. Yeah, to array, this is what I was looking for, I think. Right, so it looks like it doesn't have a set thing, so it should just work like this. So path equals path. Now, how to test this? Well, let's go through the steps and see if there's anything we're missing. Okay, Nav Agent. I press return. This is okay. We are not getting a path at the moment, so we call get path. In get path, do we see the player? No, we don't see the target. Do we see a collider with that is the same thing as the player? No. Okay, then set that to true. Starting node is equal to null because it has to reset each time, so that's fine. Then we get all nodes, blah, blah, blah. This thing we don't need anymore, that works. We get the closest node. And then we tell that closest node, we are the agent, we want to move, this is our target, and now find us a path. So, it will go to this one, we go find us a path, this will add itself to the path. So this is going to be the starting node, the first one, so it should work. So this is just one index. If this node itself sees the player, it will just tell the agent to go to this node, and then that'll be fine. So search node true. Okay, so we don't repeat it. We get all nodes. Okay, do we see the target? Can we see the target position? No. Actually, yeah. Do we see the target position? No. Actually, no. Do we see the target's position? Yes, we found the target. What happens? Okay, found target means we go to the agent, we give it a path, go to the agent, getting path false, we clear all nodes. So we stop the pathfinding, basically. If we can't see player, so if we can't see the position, but rather we find the collider of whatever we're looking for, then we do the same thing. If not, and this is the interesting part, then we need to pathfind. So we're looking through all nodes, looking if it is within the distance. So let's just double check this. So if distance transformed of position to all nodes I transformed position is less than sight range, so if it's within the range, which is defaulting to 20, so that should be fine, then we check, has that node been searched before? If not, if any of these are true, it just doesn't do anything. If it has not been searched before, then we can check, okay, do we actually see it? Is there something obscuring it? If not, then we go to that thing and we give it the nav agent, we give it a nav target, and we give it the path. And this is the thing I've missed. See, this is why I do it. I've missed the thing because we give it the variables, but we're not actually calling the function on those. So we need to do all nodes I dot get, no, not get, no, find path, that is it. Find path. There we go. Right, so a bunch of nodes around this one. Find one, give it the agent, the target, our path. We tell it, okay, go, find us the target. This node here will then be inert because it will have searched node to true, which means it cannot act again. This is in a for loop. Yeah, this is in a for loop, which means it already will have informed all the nodes it can see to look for the player. So there's no point in calling it again because this will all happen before the player will have been able to move. So if it can't see the player now, it will not be able to see the player in the future. So we don't need to double check it. So they've all searched it. So then this will just continue the loop. It will go to the next one. It will have this set, that set, that set. And then we'll continue looking for it. And let's just see. Actually, wait, then we don't need this, do we? Do we? Ah, we do, but no, it's just clearing it. Oh, no, we don't need it then. We don't need the visible nodes list because we're doing it differently. Originally, I had planned it so that it looks through all the nodes, puts the ones it can see into a list, and then looks through the list to activate them. But like this, I can just go through all of them. If I have to go through all of them anyways, there's no point in going through that extra step of putting them in a list if I'm just telling it to them directly, so I don't need to do that. So that should work. So if it does find the target, tells the player that it's found it, what does the player do? The player right, so we get the path, but we don't actually Right, so how do we do that? Because it doesn't actually update the position yet. We've got the path, but we need to update the position. So, okay, we need to do this in update. So, let's read chat. There might be some interesting stuff in chat. Finish whatever you need to finish in this stream and it should be fine as silt. Could have pasted the all nodes but it's fine. Oh, I see. Yeah, it's fine. Don't worry about repeating yourself. Not sure about resetting. Resetting what? You're sure about resetting what? Add node. List.add node. Well, I'm not sure what the context of that was exactly. Print navigational node added. Navigating to next node. Excuse me, sir. I'm an agent. And what is your business? I'd like to move. Move? Yes. But yes. Good thing you found it, exactly. We've got the path, but does the path get set? Yes, it does. It does. It gets set, but we need to update the agent's move destination, move dest, to be equal to the next destination. We could just do that every frame, and that should be fine, because it only needs to do a little distance check, and that should be fine. Although we will need to reset the index, which is something that I might do later. Yeah, oh, I see. You said before that you didn't know if it could reset it. If you could reset it. Reset what? Sorry. I think you were talking about the target. Resetting the move dest, that's it. Oh, resetting the move dest, that's it. Huh. I'm not sure what I was saying then. Alright, that. Alright, I remember now. Yeah, it has to be the index, so I have to clear it, which is an important thing. Actually, do I? Do I really? If I set it to the path, tell you what, let's clear it just in case, just so we don't get any issues. It should be redundant, but occasionally a bit of redundancy is helpful, especially when building bridges and ships. So, path.clear. So we're clearing the agent's path and then setting it anew. I think so, might have confused it. Let's clear it, yes. Okay, now that that's clear, wink wink, let's continue. So, every frame we need to check if... Okay, let's just do the code first when we first get a list, and then reset the index later. So, if the list is not empty, so if list dot length is larger than 0, so if there are elements in the list, that not list.length, path.length, of course, then okay, it's larger than 0, then we need to check how close we are. So we actually need a thing as well, a variable. Let's just put it there. So do public int path index. And let's do path node index. Okay, so then right, so that should work. Yeah, that should work. So just thinking it over, going over it in my head. So right, we've made sure we've got a list of nodes. So then we need to check the distance to the node we're currently at. So actually we need to set the default this to 0. Not sure if we need to do that, but I'll do it anyways. If vector3 dot distance between, so distance from us, so transform dot position to path index I, so the node work. Actually, no, it's not I. No, that's wrong. We need to get the index of path node index. So if the distance between us and the index of the node that we're at. Oh, hello, Tom. Thomas Poggers 60163. Hello, welcome. The stream will be ending soon, but I'll just finish this little bit of coding and then we'll be done. How are you, by the way? How are you? I'll rechat. Oh, well, let's do it now. Aha! It's a good old Brunel maneuver again. Yes, you got the reference. I'm glad you did. So, if the distance between those is less than, let's just say 0.3 meters. So this distance check. So say we've got a node up here, the player's down here, or the agent is down here. It should move to the node and then go to the next node. So what I want to do, because it doesn't move in infinitely small increments, we can't exactly compare the two positions. We have to do it distance based. So we're moving up. So if it's moving fast, it could be a frame here. Then the next frame it's here. The next frame, actually with move towards, I guess it would work. But I'm not sure that I will use move towards in the final product. So it could be that it's here, that's moving in the direction. So it moves up here, and then it's too far. That's moving down and up and down and up and down. And doesn't get to the position. So I have to check for a radius. So if it's close to it, then it starts going to the next thing. I'm just going to use 0.3 meters. Seems like a good value. So if it's less than that, actually let's do less than or equal to that. Just for fun. So then we're at this index, we're at this node, then we need to go to the next node, which means I need to set the index of which node we're at increased by 1 basically. So no, we need to check something else. Okay, so we need to do that if there are more nodes in the list to look at. If we're already at the final node, then we can't go to the next node. So if path node index is smaller than path dot length, if it's smaller than that, so if we've still got nodes in the list to go to, then we're going to increase path node index by 1, so plus plus. So then we're going to the next node. And well, we don't really have to set the position every frame. We can just set it here. Right. Let's the move destination, sorry. So let's do move dest. So when we get to the next node in the list, so when we get to a node, then we update the position to the next node. So we get to the node, we increase the index of the node we're looking for, and then we need to set the position. So move dest is already a vector 3, so we don't need to do dot position because it's already a 3-dimensional float. It works. Well, technically it's not a 3-dimensional float because that is a specific thing, but it's essentially the same. Sorry. Move dest is equal to path list with the index of path node index, which we've just increased. So this is already the next node. And since these are nodes, we need to get the transform.position to get the coordinates of it. So this will work for all nodes except for the first one, because the first node, if the first node is outside of this range, then we cannot get close enough to it to set the destination that we're moving towards to the next node. So we need to do that. Actually, should we? You know what? We don't even have to do it via the node, via the node, because we're already getting the closest node to us. Which means that we can just set, because, okay, so the first node in the path list of nodes is the first node that we've basically, where we spawned, where we seeded the paths, which is the closest node to the agent. So that node is always going to be first on the list that we go to. So we don't need to go to the node script itself and set that position to the position we're going to, because the agent already knows which node is the closest and which node will be at the very bottom of the list. So actually, no, I guess. Okay, so I guess top of the list as in it comes first. Bottom of the list as in the element that is, well, that is added first if you add on top of it. So basically the first element. And element is just a word in coding which means an entry in a list or an array. That's an element of the list or array. So, got this. So where is it? Get path. Where is it? This is, okay, we can't see it. Don't hit it. So then, yeah, it gets the closest nav node. Let's just do nav node. So, no. Let's do navigation node, just so it's a bit easier to see. So, after we've told the starting node to go, basically, to find us a path, then we can do move dest is equal to starting node dot transform dot position, which should get us going. So then we're going to the first node in the list. When we get to the first node in the list, then this code will run. It will take us to the next node and to the next node and to the next node, and that should be fine. Now, there are two ways that I can think of two cases at the moment where we need to reset the index of... Okay, so basically... Actually, do I need to do that? No, I can just do it. Of course, I can just reset the index from the node. Right, sorry, let me explain. So, the index goes up and up and up and up. Say we reach the destination we were walking towards, the end of the path, but the player has moved on since then. So now we need to generate a new path. When we're generating this new path, the index needs to start at 0 again, because the list of the path will be cleared, and then we'll start from the beginning. So we need to reset. So, okay, two options. One, we get to the end of the path, can't see the player, so we need to generate a new path, and that's that. We generate a new path, reset it. Next option is midway. So we're going midway, and say every 10 seconds or so, if I want to have an AI agent that tracks the player, follows the player, then if the player moves around, it wouldn't really be very good if the AI agent went all the way up here, then, oh, the player's moved, and then started going down there, and then went all the way up there, and, oh, the player's moved, and then went over to there. So every 5 seconds updates. So as it's moving to the next index, it needs to update the index, and then move to the first node of that new path. So, all of that has in common that a new path has finished, so that's where I can reset it, which is just in the node script. So that is down here, where we say, yeah, Nav Agent, we clear the path, we set the new path, we set it to false, so it's no longer getting the path because we've got the path. So all I need to do is just in here, just do Nav Agent dot, oh, what do you call it? Let me just copy it. Path node index, there we go. Path node and node index is equal to 0. Now, are there errors? Are there errors? Yes. To create the definition of a length. Oh, right, of course, because it's a list. 32, Nav Agent 32. Yeah, sorry, that is my mistake. Actually, wait, no, it's not. It is my mistake, but the other way around. So, wait, what? There's not a definition for length. No accessible method for length. So, path is a list. Oh, right, of course, it's count. Yes, sorry, bit of syntax error. So, you've got an array which has elements of a thing, but it's static, you can't add to it easily. The length of that, so how many elements it has, that variable for that is called length. With a list, how many elements it has is called count. So yes, when I'm referring to path length, I need to actually refer to path count. Cannot convert from node to vector 3. I've probably just missed the thing, which is Nav Agent 34. Right, the position, of course. So the node doesn't have a position, so we need to go path node. So we're looking at the next node that we're going towards. So we need to do path index of path node index dot transform dot position. All nodes does not exist in the current context. What? Nav node 57. Nav node 57. Oh, I see, because this gets collected up here. Tell you what, might as well do that in start. That's fine. So it's because I was referring to this variable, all nodes, in a different function down here. But this variable is created within the function of find path, which means it's local to that. It can be accessed within anything inside this function, but it can't be accessed from anything outside the function. So to fix this, I'm just going to make it a private variable up here. So I'm just going to, no, not like that. Actually, no, that should work. So let's do nav nav node array, all nodes, and let's see, public void start, and then I'm just going to assign it here. Hopefully that should work. I may need to assign the array to something beforehand. No, that's worked, and now there are no errors. So, to test this, let's add a wall. An obstruction, if you will. Actually, let's not make it this tall. Let's make it... sure, let's make it like 10 meters tall. Move it 5 meters up so it's sitting on the ground. Let's do it like this. So you can see this wall is clearly blocking line of sight from the ball to the cube. So, be interesting to see what the thing does. Does it work? Does it break? Press return. It's going to the closest one, and what does the path say? Oh, the path wasn't assigned. Why wasn't the path assigned? Don't worry, I'm not going to fix this now because it would take way too long. So find path. This thing's find path got called. Which means add this, add to it. That did it not find the target? Actually, one quick test. I want to see if the searched variable updates. So this one, you can see over here, has not been searched. So I'm going to open the path up as well. Oh, tell you what, it might be the distance. It might be the distance. So, right. I'm going to just... No, tell you what, I'm going to do it here. So distance, I'm just going to say 2000. Just for the test. Does that work? I'll need to reset the components. There we go. Now let's see if it works. Because these are quite far away in the world, so... Oh, null object reference. We've got something in the list, though. Okay, that is too much now. We've gone a lot over time. Can't do this now. But it is a good start. It is a good start. We've got most of the logic down. Now it's just a matter of debugging it. So, with that, let me read chat. Hello, I saw you've joined at the beginning. Ooh. But I wasn't sure if you were a bot or not. But it's great that you're not. Welcome in. Shredis, he followed you 13 hours ago. Oh, did he? Oh, well. Shouldn't you be getting home if you followed me all the way here? I mean, it's night time, so I think, yeah. Thanks for following me. Right. Oh, so 3D floats are an actual thing? Of course they are. Of course they are. You can add as many dimensions to them as you want. Never knew. By the way, at Tom is Puggers. Is your number by any chance based on 60163 tornado? I don't know. Path.countess. Ooh, wall. Yes. Yes, that is true. Thanks for the stream. Shadows, you missed some above Tom's approach. Oh, did I? Sorry. Did I? Where? Which ones? Below resetting the move desk. That's it. I think so. Might have confused it. Let's clear it. Yeah. Yes. No, I did read those. I did read them. Ah, yeah. Aha. It's the good old Brunel maneuver again. I did read those out. So, yes. It. Yes. Bye. Yes. Bye. Just shout outs at the end. Alright. See you tomorrow. Mr. W, thanks for joining, and I wish you restful dreams and a good night. Bye. Indeed. So. Oh, and I've just seen This stream has gone the full 2 hours, so that's good. Weird, I didn't realize. You were probably focused on typing something else. Anyway, so shoutouts. Kangafango does lovely stuff on Sundays. He streams obviously 2 map development, trains map development. He also streams train driving, truck driving. Very interesting stuff. It was a very nice stream. Actually, weird, didn't realize. Sorry, thank you. It was a very nice stream. I think so too, even though there were quite a few technical issues in the beginning. Technical issues, I tell ya. Anyway, many thanks for the shout out. No worries. Also, there's a project, you probably know Trains. There's a project going on in that. It's a huge map. It's being developed. It's for free. It's on the DLS. It's called Central Europe. It only got updated a few days ago to the newest version. If you have Tiers 19, might as well have a look at it. So, yeah. Might stream Tiers 19 this Sunday. Anyway, not this evening. This evening is already past. It's night now. Anyway, need a bit of water. I've been talking quite a lot. Nice. So, feels much better now. Much better. So, thanks again. Bye. Yes, this stream will be archived on YouTube, as you probably know. You probably know that this stream will be archived on YouTube. So, right. Bye. Hearts.